Well, first of all, I think we are Neumann, so well known since 82 years for transducer technology, but only on the front end, where the microphone starts to be the first tool in the recording chain, where we transfer natural signals into electronic signals, natural sound into electronic signals, and I think we have done over the history of our 82 years so many other products which have been supporting the signal processing chain, that it was natural to think about the other end of the signal processing chain and convert the electronic signal into natural sound again. And having had the opportunity within the Sennheiser group that the Klein & Hummel, as a loudspeaker manufacturer, a well-traditioned company in Germany, was already part of the group, we talked about it and we thought about how we could cope and work together. And the decision was made after 4 years with Klein & Hummel that the speaker line of Klein & Hummel will be discontinued under Klein & Hummel and will be split into two areas. The installed sound part under Sennheiser, and studio monitors should go under Neumann, because Neumann is so well known in the world of professional recording studios. And then we said, okay, we will not take any other product and just change the logo from K&H into Neumann and sell a product which is not ours, but we would be willing and more than happy to re-engineer such a product. The first result is now the KH120, which is the beginning of a whole lineup of studio monitors, and we are redefining the sound on the other end of the signal processing chain now.
Yeah, so we can start off with the cabinet. It's an aluminium cabinet, so it's very robust with a strong painted finish. It will take the knocks that we see in everyday life in loudspeaker usage. Also the grills on the front, also very robust, so you don't get this pushed-in tweeter syndrome that we often see. We also have a titanium fabric tweeters. The titanium tweeter gives us a pistonic movement, which is what a loudspeaker needs to do. It needs to move backwards and forwards and bring sound to the listening area. We need to do that in a very controlled way, but we also don't want to see breakup modes on the diaphragm itself. So then we have the fabric dome that's part of the construction, and that damps any breakups. Same with the woofer, we don't want to see breakup modes on there. And we avoid that by having a sandwich construction, so we have good internal damping on the materials used for the cone. You can also see the two ports there, the very high capacity ports, large cross-sectional area, which means they then have to be quite long on the inside, and we want to avoid resonances in there, and we have a patent applied for a technique to avoid that. You also see that they're on the front, which is quite advantageous, because if you have, let's say, an OB van, you can imagine there's not much space in an OB van. So then you have lots of things around the immediate surroundings of the loudspeaker. And then if you had a rear-ported loudspeaker, how would you get the sound from the back to the front? So we don't have that problem because the ports are on the front. On the back of the loudspeaker, we see acoustical controls. There's a bass control to compensate for the loading that we see from walls behind the loudspeaker, which is very common in a studio, and you see that in this room here. Also we have a low mid control, so we see loading from a mixing console or any desktop that's in front of the loudspeaker. We can reduce the bass that would otherwise cause a very boomy sound. And then finally there's a treble control, which is more cosmetic in that some listeners prefer a little bit less treble, some might want a little bit more. I tend to leave it flat, I'm happy with that. Additional features on the back are a switch mode power supply, which means you can take the loudspeaker anywhere in the world and use it in the US or in Europe, or go over to Japan if you're suitably internationally orientated. It's also a very robust, poor quality power supply, so if the power supply is going up and down, then it really doesn't matter to us. We'll take it in and use it as it is. There's also an analog input version of the product, which is probably the version that most people would buy. We also have a digital input version coming in the future, and that'll be 24-bit 192 kilohertz. And also with a built-in delay feature that allows you to compensate for time of flight differences. If the centre speaker is a bit further forward, you can then delay the speaker back. Additionally, it has a very long delay, so we can compensate for video delay, so lip sync. You often see a 2-frame delay on an LCD screen, so we can easily introduce that to the loudspeaker there to compensate for that. So what we're doing here is we're placing the tweeter into a shape on the front panel, and in acoustics it would be called a horn. If we called it a horn, you'd think of this sort of sound quality. So this is not very good. So we give it a nice marketing name. We call it mathematically modelled dispersion waveguide, because that's exactly what it is. As time's moved on, computers have got faster, and modelling techniques in computers have got better and better and better, and you see the researchers are able to do more and more. So we're taking some of these techniques, building them into a model of the sound as it spreads out from the diaphragm. Starting from there, we model the driver itself, and then we can create a model that simulates how the sound spreads out from the loudspeaker. We can then set a target response that we want to see in the room, and then press go on the computer, come back in 2 weeks and have a result. The advantages are that we reduce the effect of the reflection off the mixing console and also from the ceiling in the vertical direction. So you can see that it has a narrow vertical directivity. It also has horizontally, it's very wide directivity. So if you're moving left and right along your mixing console and you go all the way to channel 1 to adjust something, you still get a consistent tonal sound quality from the loudspeaker. It doesn't change so much from the centre to the left and the centre to the right. So from a practical point of view, it's very useful. Also, as you move around within the room, you have a consistent sound quality, and people who've been to the demonstrations that we've had have observed that even from the back of the room. They come to the front and say, "Ooh, it sounds the same."